Hello friends, this is Sushrut Tendulkar and welcome to my YouTube channel. In this video, we're gonna learn how a simple neuron works along with the activation function. We'll then learn a simple neural network and the architecture. And finally, we look into the intuition behind the training of a neural network. Let's get started. Components of neural network. There are several moving parts to a neural network. The basic building block for any type of neural network is a neuron, which loosely has similarity to our own biological neuron. In this video, we'll focus more on the basic building blocks of neural network. How a simple neuron works. A neuron takes inputs, does some math with them, and produces one output. The image shows what a two-input neuron looks like. Three things are happening here. First, each input x1, x2 is multiplied by weights w1, w2. This is indicated in blue. Second, all the weighted inputs are added together with a bias b indicated in pink. Finally, the sum is passed through an activation function which produces the output y. The activation function is used to turn an unbounded input into an output that has a nice predictable form. A commonly used activation function is the sigmoid function. A sigmoid function outputs the number in the range 0 and 1. No matter what the input is, the output will always be between 0 and 1. Let's see an example of neuron working. We will initialize the weights and biases W and B. So W1 is equal to 1, W2 is equal to 2 and B equals 3. We'll then take random inputs to the neuron x1 equals 3 and x2 equals 2. The neuron will first multiply weights with the inputs. W1 times x1 becomes 3 times 1 equals 3. W2 times x2 will become 2 times 2 equals 4. Bias is 3. These will be added and passed into a sigmoid function that will become sigmoid of 10, which will finally output the value 0.999954. Let's see how this neuron can be coded in Python. We'll first define a sigmoid function which takes one input. Sigmoid function is nothing but 1 divided by 1 plus e to the power of negative x. Neuron will call this function after it has calculated the weighted sum of inputs. Next, define a class to represent the neuron. The init function takes weights and biases as input and assigns it to the corresponding variables. The forward function takes inputs x1, x2 in our example and multiplies them with the weights that are initialized. This function will add bias to the weighted sum, and finally it calls the sigmoid function with the calculated values. We'll randomly initialize the values of weights to be 1 and 2 and bias to be 3. We'll then create an instance of the neuron class we created earlier. Finally, we assign some input values and call the function using the instance we created. This gives us the output 0.999954, which is same as what we calculated manually. That's how a simple neuron would look like in a Python, and here is the complete code for the neuron. This architecture is simple to understand, but we cannot achieve much with this. We need to be able to combine this with multiple neurons so that we can achieve some tasks. Let's construct a simple neural network by combining the neurons. A neural network is nothing more than a bunch of neurons connected together. This network now has two inputs, with one neuron. Let's add one more neuron to it with same inputs. Keeping the earlier neuron in mind, we just add new weights and bias to this neuron. Let's call them W3, W4 and B2. Now, if we keep the same weights like W1 and W2, then there is no use of having this extra neuron because both the neurons would produce the same output. Each of the neurons produce one output which can be fed into a different neuron. Let's call the outputs as H1 and H2. These two will get fed into a neuron with different weights W5 and W6 with different bias W3. This neuron outputs the final value Y. Now that forms a simple neural network. By convention, we call each set of neurons as input layer, hidden layer and output layer. Now we have a neural network, but it will be of no use if we don't train it. What does training mean? Training simply means that updating the weights in the network such that it produces best output. Let's see some of these steps in training. First, we need to design the neural architecture in the sense that how many neurons you want to have in each layer and how many inputs your neural network would accept. Next, randomly initialize the weights and biases. Think on forward propagation algorithm. In our example, we had taken an algorithm that would multiply inputs with weights and pass it through a sigmoid function. Decide on error function for optimizing the weights, backpropagate to compute the error vector, and use gradient descent with backpropagation to minimize the cost function. We'll next see the intuition behind this process using simple steps. We have our neural architecture here. We want to use to solve some problems. Let's take a look at a dataset. This is a dataset for predicting the house price based on floor space and number of rooms. So, floor space and number of neurons will become the inputs to the architecture, x1, x2. What are we trying to solve here? We want to find a set of numbers which, when multiplied with floor space and rooms, will give us the price of the house. For example, 71 multiplied with something plus 4 multiplied with something gives us 250,000, or 98 multiplied with something plus 5 multiplied with something will give 209k. Now what are these somethings? These somethings are nothing but the weights we have been defining. W1, W3, W5, etc. Let's look at them closely. In the training process, to start with, let's fill random values to the weights, say 3000 and 10,000. If we multiply this with input values, we get the output as 253,000. This value is not same as the actual value 250,000. What do? We correct it. For that, we'll take the help of a function called error function. All it does is calculate the difference between the calculated value and the actual value. There are many types of error functions that are being used with variation of this logic, but the whole idea is to capture the difference between the actual and the predicted values. In our case, the difference is 3000. If you observe this number, it says two things. One, the number is positive. That means that calculated value is more than the actual value and hence this must be reduced. 2, the difference of 3000 says that by how much value the calculated number is more than the actual one. This information is used to reduce the values of weights. Both this information must be passed into the initial weights and must be updated. Based on this information, let's update the weights and calculate the new values. We now got a new set of numbers and hence the new error term. Now this error term is better than the previous values because the newly calculated value is closer to the actual value. We again look into the error and pass this information to the weights so that they can be updated accordingly. Now we have to repeat this for every training example, and this is the intuition behind the backpropagation. Once we train these neural network with more training examples, the weights get better and better and will be perfectly able to predict the house price in our example. Now this process of calculating the error term and passing that information back to the weights is called backpropagation. And that's a high level intuition behind the training of the neural network. Let's recap what we studied today. We saw how a simple neuron works and a Python example for a neuron. We then saw the architecture of neural network and understood the intuition behind the backpropagation. Well, that's it for this video. Thank you so much for watching. Keep learning. Bye-bye.